Okay, hi everyone. I'm Colin. I'm going to be running this open class talking about our AP Physics courses tonight. So for me, I've been a teacher both in the classroom and online for many years now. I have a bachelor's in physics and a master's in teaching. You're welcome to take a screenshot if you have it of my background there. I'll just give you a minute to read that if you'd like. Right. Okay. So just to give you an idea for the agenda for tonight, I'm going to give you a brief overview of like AP Physics versus SAT Physics, because I know some people are interested in taking those different tests for upcoming years. And then we'll also talk about Physics 1 and Physics 1 and 2 versus Physics C for those who are choosing their class for next year. And then we'll also talk about some example problems and physics courses for next year. All right. Okay, so AP Physics and SAT Physics are really completely two different styles of showing your preparedness for college level sciences, right? So AP Physics, you're looking at taking an entire year high school course. Typically, it would be either devoted towards just doing Physics 1, Physics 2 would typically be like a second year course. And then there's also Physics C, which of course is calculus based, which could be a 1-year course or a 2-year course, depending. Versus SAT Physics, you could take with any high school physics, really. Now, it's typical that SAT Physics would cover things that you have not learned in high school physics, which is why we have a separate course for that. I'm not really going to be talking a lot about the SAT Physics necessarily tonight because we're in the middle of AP Physics season. We're going to kind of devote most of the time to that. But those are also some another course offering that we have to help prepare people for SAT Physics. Basically, breaking it down, we do a full concept review of all the different things that you would learn in SAT Physics, which include a lot of things that typically aren't taught in any high school physics courses. But we go through all those as well as just doing practice and the types of questions that go on there. So I said tonight we're going to be focusing mainly on AP Physics. So typically you take the AP Physics test in May, right at the end of your year of physics, so which could be Physics 1, Physics 2, or Physics C. The thing that makes AP Physics different than, say, the SAT Physics test is that it tends to be more focused on methods and content and how they work together, how the skills that you've learned throughout the year, in addition to the content knowledge, versus SAT Physics is more like can you answer a specific question on a specific topic, not as much the scientific processes, not as much of the skills required to function in college. So some places strongly prefer the AP Physics there. So for AP Physics, right, there's 4 different tests that you could take: Physics 1 and Physics 2, which are non-calculus based and are much more like I said, process intensive. And then Physics C, which is calculus based and focuses on that. So for those taking Physics 1 for a whole year, that would typically be a whole year course, and then Physics 2 would be a second year course. Physics C, it really depends on your school. You'd have to ask how your school runs it. A lot of times they would do Physics C after somebody has already taken a first year physics course. So either honors physics or something like that. Then you can move on to physics C, and they might try to do both tests in 1 year, or sometimes they would just spend the whole year on, say, mechanics and make that a whole year course, or they might, and then electricity and magnetism might be another year course. So another big difference, AP Physics, you can earn college credit for it depending on the university. You'd have to check with them. But those who earn higher levels, usually you'd have to get a 4 or a 5. But it is possible to get college credit for that. And even if you go to a school that doesn't take that AP rollover, it still does look good to have AP Physics on your transcript. Versus SAT Physics would be purely for college entrance to show, hey, look at how I have shown a mastery of SAT Physics or throughout my learning in high school. All right. So the big differences between Physics 1 and 2 and Physics C. So Physics 1 and 2, like I said, is algebra-based. It focuses primarily on processes. Skills, I would say, are actually more important than actual content knowledge. So like the skills that you would use to analyze data is more important than having memorized a lot of data. Laboratory equipment, specific pieces of equipment that are part of the AP curriculum come up frequently on the test. Physics 1 is a first-year course. Physics 2 is kind of the second-year counterpart of Physics 1. Physics 1 assumes no prior knowledge. Physics 2 kind of picks up where 1 leaves off, and it covers completely different content, but in a similar style. Physics C is kind of a leftover from the previous. It used to be Physics A, B, and C were the tests. So C is still left over, and so it uses kind of the old style of questions, both for multiple choice and for free response questions. And the Physics C questions are, I think, in my opinion, a little more straightforward. They don't necessarily involve as much heavy language. So if your math skills are very strong, but reading and writing necessarily isn't, the Physics C might actually be easier for you. But it is calculus based, so you have to be able to reason in that way. And it's going to be much more dependent on, say, derivations and things like that. The Physics 1 and 2 do use derivations, but not to the extent that Physics C would. Also, like I said, calculus based. Laboratory processes and such are still part of the Physics C, not to the extent that they are in Physics 1 and Physics 2, but they still play a major role there. All right. Oh, and in case I didn't mention that, so Physics C is 2 separate tests. So it's mechanics and electricity and magnetism are 2 completely separate tests. So that could be in your high school, they could break that up into 2 separate courses, or they could have you take the full year together and then you just take both tests. So then there's a possibility you get credit for both of those at the college level. And again, you have to check with your high school and the universities that you're applying to find out about that. So some changes specifically for this year. So for people who are interested in our mock test prep that's going on right now, basically for this year, they've decided that they're going to do away with the multiple choice portions of the test. They're shortening it down because usually it's like 90 minutes of multiple choice and 90 minutes of free response questions. So they're doing away with that and replacing it with 1 long free response question and 1 short free response question, no multiple choice. For Physics 1, the questions are going to be, the long question is going to be of the quantitative qualitative type, which is one of the, normally there are 2 long questions and 3 short questions. And so one of the long question types is the quantitative qualitative. So this year they're going to have just that long quantitative qualitative question. And then for the short question, they're going to use what's called the paragraph length response, which is, I think, the hardest type for students because you're used to, especially in math and science, reasoning using equations. And for the paragraph length response, you have to reason entirely using a paragraph of prose, essentially. So in our preparations right now, we're focusing especially on those, but also on all the topics that are that could be coming up on this year's test. For Physics C, they're going to have one question that's more of the long question is going to be more of an analyzing, explaining type of question, which is pretty typical. And then the second shorter question is going to be more experimental design related. They also, because of a lot of schools are dealing with a shortened school year, they've decided to basically cut off the amount of topics that are going to be covered on this year's test. So for Physics 1, basically there's usually 10 topics and they've cut off the last 3. So those are basically electricity, static electricity and currents, and then also waves. So all the waves and electricity stuff is not going to be on this year's Physics 1 test. And then for Physics C mechanics, they're basically have cut off the last 2 sections, which are oscillations and gravitation, or everything universal gravity related. So yeah, so that's how the things are going to change this year. And so for the mock test that we're doing right now, we're going through and analyzing those, especially, but also doing kind of all kinds of test prep as well. All right. Okay, so I don't want to spend a whole lot of time talking about multiple choice, other than to say that when we're going through these, we do some multiple choice even for this year's test, just because the multiple choice hits a lot more topics than the free response do. The free response question, on a given year, there's 5 questions. Well, for example, on Physics 1, there are 10 different units. So only half of those units, or some questions hit multiple units, but maybe only half those units actually get hit on a given year. And so maybe you have one question on a specific unit, but it doesn't cover every possible little nuance or topic. And so when you get to the actual physics test, you're going to see things that you haven't seen before. So we still do go through the multiple choice test because it allows us to hit a lot more topics and kind of test for a broader knowledge base. But as you can tell in physics, for those who are kind of looking at their test for next year, this is a very typical Physics 1 question. So you see that it has a very long prompt, and then each of the answers are, between a short sentence and a long sentence. So sometimes there are, shorter answer kind of questions on the Physics 1, but when they switched from the Physics A, B style to the Physics 1 and 2 style, one of the things they did was they had a lot fewer questions in the same amount of time, basically allowing them to require more reading and analyzing type questions. So the questions are longer, they require more reading. It's easy to get lost and miss small little details if you're being careless, or if your language skills aren't as up to a high level. All right. So we would go through and we would analyze this, learn how to go through and pick out important pieces of information, and from that be able to reason our way to a conclusion. All right. Versus this is more of a Physics C type question. I would say you'll see both of that kind of on both tests. So I don't want to say that it's exclusive to one or the other, but it's much more common on the Physics C that you'd see exact numerical answers and equations as answers. So here we see an equation where we're given the equation for force, and then our answers are in potential energies. So that would mean that basically we are going to use the equations that we know involving force. For those who have done this before, that this requires the use of basically a calculus equation. So we have to integrate the force over the distance x. So we can substitute in that our force equation that we're given up here, do the integral to solve for that change in potential energy that we would see there, and then so that gives us the equation for potential energy for this specific one-dimensional conservative force. All right. Okay, so this example shows the typical free response question for Physics 1. So this is an example of a paragraph length response. This is one of the kind of trickier ones that I've seen because for Physics 1, free response for the paragraph length response. Typically, they'll have one or two kind of prompting questions that kind of tell you what kind of answer they're looking for. Maybe it'll have check boxes that say, agree or disagree, or maybe say, greater than, same as, less than, something like that, that they would give a couple of points to, and then it'd be, say 5 out of the 7 points would be for the paragraph length response. This specific one, it was just 7 points for a paragraph length response. So how we would analyze that, so indicate whether the speed of the block is going, so that would be probably 1 point. The rest of the points are going to be involved in how do you explain that, what physics principles do you show, and then you have to justify that right in your clear paragraph length response. So like on this one, they give you a point for just mentioning the use of conservation of energy. They give you a point for using momentum. They give you a point for correctly using the different physics principles that you'd have to use to analyze this question. And then the students would do this on their own, and then we go through it as a class and grade these. The students grade their own, and so they can see, okay, this is how the points would come about. So I know that when I'm doing this for reals on the AP test, that I'm writing it in such a way that I make it easy for people to give me points on my questions, because I'm writing it in a style where it's easy to pick out questions and where I'm demonstrating my knowledge very explicitly in the way that the graders would be looking for that based on the keys that they have. All right, here's another Physics 1 free response question. So this is an electricity question. So again, this is one that wouldn't be covered on this year's test, but it's a good example of quantitative qualitative reasoning. So the quantitative qualitative reasoning is one that's specific to the Physics 1, Physics 2 style of questions, but they'd like to ask, so they'll give a prompt like this where they say, okay, student 1 says this, student 2 says this, and typically at least one of the students is mostly wrong, but they say some things that are correct. And student 2 might be correct. A lot of times they're also partially correct, partially incorrect. And so it's kind of pretending like you have two students working through a homework assignment, they're both wrong, but they're trying to argue with each other, right? And so what they'll go through and they'll say, okay, which aspect of student 1's reasoning, if any, are correct? So you're expected to basically be able to pick out and say what aspects are correct, not is their final conclusion wrong, but is their suppositions correct? What part of it is wrong and what is right? And then this question then goes on to, okay, what aspect of student 2's reasoning, if any, are correct? And so you're supposed to go through and pick out, okay, what did student 2 say that was correct? Then it goes on, what did student 1 say that was incorrect? And what did student 2 say that is incorrect? And so there might not be something for each one, but they expect you to be able to go through and figure out what that is. And so it requires you to go through and be very specific about what you do know and what you don't know about each of these topics. So for example, on this one, we have a parallel circuit and a series circuit. And so student 1 says, okay, bulbs A and B will be brighter than C and D because in a series circuit, each bulb gets all the current coming out of the battery. But in the parallel circuit, each bulb gets only half the current. So for example, you'd have to be able to say, okay, they are correct in saying that in the parallel circuit, each of the bulbs only gets half the current, but they're incorrect that bulbs A and B would be brighter. And you'd have to be able to pick those out and explain that during the in the responses below. All right. Okay, so then here is another question that's more, well, it's a physics C question. It is dealing with, again, another topic that's not being covered this year, which is oscillations. So in in this particular question, basically, we have an oscillator, and we go through and look at the types of answer or the type of prompts that we have. So we see it is still a longer prompt because it's a free response question, but the answers that the individual parts to it are pretty simple, right? So determine the equation for v of t, including numerical values for all constants. So we see right off the bat that you're expected to create an equation based on what you know. So it's not necessarily analyzing the situation, what's going to be conceptually happening in the problem, what aspects of this or that are incorrect. It's okay. What equations would we use to analyze this? How can we state that in mathematical terms? So that'd be much more common for Physics C. Okay, so how can we break this down? So to do part A, we would, determine the equation. So I would have to know, from my equation sheet, I could use the equation sheet, but that the velocity is going to be, based on V max times sine of omega t. Okay, and then I also have to know that omega is going to equal 2 pi divided by capital T, which is my period of oscillation. And I have to know, okay, how do I interpret that from the graph? Both tests like to use a lot of both physics 1, 2, and C like to use graphs, and they like to make you analyze how do I take important information from the graph and apply it to what do I need to know. So here we need to be able to find these important things. We need to be able to find V max. We need to be able to find the period. We need to find our frequency. So here I can look at this red line over here and see that it looks like my maximum velocity is about 0.16. And then I can also look at this other red line. It looks like my period of oscillation. Looks like it's about 0.7 seconds. Okay, so then I also can look at this and say, okay, well, it's initially going down and it's starting at equilibrium. So that means I'm going to be using a sine function, not a cosine function. It's going down, so that means I'm going to start with a negative value. So it's going to be negative sine instead of positive sine. Would be going initially up. And then I can put all that info into my equation, solve that out. And then so I get here an equation for motion for this particular oscillator. Now for part B, it says, given the equilibrium position at x equals 0, determine the equation for x of t, including numerical values for all constants. So immediately, seeing that x equals x of t, I'm going to know, okay, that means that sorry, there's some people having audio issues. Okay, hopefully, sorry. Sometimes my computer microphone has issues. I tried using a headset, but it wasn't working tonight. So anyway, sorry about that. So in this next part, we'd be finding x of t, right? So which is going to require us to integrate this equation that we've already had. So again, that's something you wouldn't see on the physics 1 and 2 test, having to find an integral, being able to find one equation from another equation using calculus, but we would do that. And so we would just integrate this sine equation, and we would get a cosine equation that would demonstrate our position as a function of time, or we could take a derivative and find the acceleration as a function of time. It's likely we might be required to find force from that, which would be applying our physics principles to the calculus that we already know. But you could see an entire equation or an entire question that revolves entirely around doing derivations and solving for numbers without having to actually verbally explain anything. Versus that's a lot more rare on the physics 1 and 2 test. You'd expect to see a lot more verbal and written. Well, written reasoning, but using words instead of equations. Although in a good portion Physics 1 questions, you actually can use equations to explain a good chunk of it with the proper, written explanations as well. All right. Yeah, so we can see these important pieces from the equation. I kind of already talked about that, how we would insert those in there. All right. Okay. All right. So I think I explained some of this before, but basically, we're for this year, we're kind of past the point where the review courses are coming along. We still have 2 more review courses for review sessions left, two more mock test sessions left before the Physics 1 test, and then 3 for Physics C. So those are still being offered for this year, and then of course for next year, review and mock test portions, which basically for the review courses, that's going through and basically systematically hitting all the different topics that are going to be covered on the AP test, and doing practice questions from a review book geared towards those different topics, and towards learning the skills for specifically the types of questions that are going to be on the test. And then mock test, it's doing the mock test for homework, so doing the mock test for homework, and then we go over it in class, grade it. You get an idea for, this is how I'm going to actually do on the test, and these are the things I need to improve on going forward. So like I said, we have 2 more left for Physics 1, and 3 potentially for Physics C. Yeah, and so for those for this year, like I said, we're spending most of the time on physics or on the free response portion of those questions. So the mock tests are primarily just the free response portion, but we do also go over some of the multiple choice questions as well, to hit a wider breadth of topics. For later years, we're going to focus on both the free response and the multiple choice, and the multiple choice questions. All right. And obviously these courses are designed for people who have already taken the test. So this is at the end of the school year, right? And then for this year's test, it's for those people who are doing their kind of last minute preparations for this year's test. All right. Okay, I think. Whoops. Okay. So just some tips as we get ready for this year's. No matter if you're taking the Physics 1, 2, or C tests, it's good to focus on processes and skills that are being tested, not just the concepts. So you can study the concepts and have those all memorized, have all the equations memorized, but if you don't know, how to use specific pieces of equipment, or know how to analyze a certain type of graph, you're going to be in trouble versus, practicing with those skills. And a lot of time, and it's really hard for physics to do anything besides just do the AP physics practice questions. A lot of the test booklets are good, but the AP physics style that College Board puts out is really, really unique. And so there isn't a whole lot of substitute other than just doing those kinds of problems. Again, so I kind of talked about this and how we prepare for the specific questions, but you have to really get your mind and your head in the right mindset of saying, okay, what are they going to give out points for this problem? What concepts do they want to know that I know? Even if you don't know how to answer the problem, going, okay, what would they be looking for to show that what can I do to demonstrate that I know something about this topic, so that I can at least get 2 or 3 points out of 7. Because like I said here, on the Physics 1 test, you only need about 63% to get a 5. So if on one specific question, if you just give up and don't answer at all, that's a 0, let's say it's a 0 out of 7. But if you can at least show, okay, I know a little bit about this and that, then that goes a long way to you being able to recover on your other questions. A lot of people, we're coming from school mindset of, an A is like 90%, so I need to get 90% on the test. But for AP Physics, it doesn't really work that way, right? You have to just get as many points as you can, because the questions are designed to kind of, trip you up and, to trick you. And also they're designed in such a way that you have to, you might, even getting the correct answer on everything, you might still not cover all the things that you need to cover in order to properly explain yourself. So you got to try and have the mindset of, okay, where can I get the points? How do I answer this question in such a way that they'll give me the points that I need? Get as many points as I need, not necessarily every single point. I mean, obviously you want that, but to answer, looking for that. And don't panic if you don't get every one of those points, because again, you only need 63% to get a 5. So Physics C, I believe is actually less. The percentage is actually even less than that. So focusing on, okay, how do I get those points? How do I demonstrate that I can do these skills? All right. So at this time, I think we're going to take any questions. So you can go ahead and enter those in the chat. I'll give you all a minute to do that. Otherwise, I do have some frequently asked questions if nobody has any specific questions there. So for Physics C, electricity and magnetism, you can, I'd say you check with our operations and all that. I don't know if there's any plans to do that for this year, but you can definitely check with them. If there is enough interest, we could definitely do that. But again, it comes down to interest, and so you'd have to talk to our operations about how that's being planned. I don't know. Like I said, I don't believe there's anything in the works for this year. But if there was an interest for the next few weeks, we could probably do something. All right. So for preparing for this year's AP Physics 1, students just need to practice free response questions from past exams online or on books, not need to check on multiple choice questions, right? So I'd say, yes, they don't, I would say, yes, it's not important that they know how to answer the style of multiple choice questions for this year. Like I said, I wouldn't focus on, making sure you can answer them, quickly answer questions or anything like that. That you're, work on your timing on multiple choice questions. But the multiple choice questions typically cover like all of the topics that you would see on a typical test, versus the free response questions are pick and choose from specific topics. So if you, if for example you have topics that hasn't been covered on any free response questions, could still come up and be a huge chunk. They could have, that in the review class I was going through, I mentioned how they rarely have any free response questions on universal gravitation, for example, on Physics 1, but they might this year to be like, okay, this is a universal gravitation question, and that's the big qualitative, quantitative reasoning question. And if you haven't done any multiple choice, you wouldn't have seen those before. All right. So what is the experimental design portion of the AP test? So an experimental design portion is one where basically you're creating an experiment to answer a question. So typically it'll be like, okay, the student has this piece of equipment, and this, they're trying to find so they're going to gather this data and find this. And they'll typically ask not for the entire process of how you would create a lab, but they're asking you for a specific piece of that. So they're asking for, say, they might ask you, how do you set up this graph? How would you solve this equation for something that you could put on a graph to find that, using linear regression? How are you specifically doing that? Now, I should say that the experimental design question is not supposed to be on this year's Physics 1 test. It's supposed to be because usually those are the two long answer ones are the experimental design and the quantitative qualitative. And from what it says on their website, they're going with the quantitative qualitative instead of that. And then the short answer is going to be, usually they have two kind of regular short answer questions and then a paragraph length response, and they're going with just the paragraph length response and the quantitative qualitative. So the experimental design is basically like you're answering for specific pieces of equipment, specific graphs, and usually they'll have some portion where it's like, how would you test for this? How would you set up your experiment? And they're looking for a specific piece of equipment that would find the force on on this exact portion of the system. Okay, so they're looking for those kinds of things on there. Hopefully that answers your question. All right, so the course combines Physics 1 and C as one whole review. No, so we have one going right now for Physics 1, and then we're looking for to do one for Physics C as well. But no, we can't really do them together. So, right, so there's two different things going, and so you either sign up for the Physics 1 or the Physics C, depending on what test you're planning on taking. All right. Any other questions? Okay, so we'll go over some of these frequently asked questions. I think we've talked about some of these throughout, but so which one of the 4 AP tests is the most difficult / easy? I say that depends on the student. So if you, for like in general, probably your average high school student would say that Physics C is more difficult because it requires a strong knowledge of calculus, very strong equations, and basically mathematical analysis. So if you're average high school student, that would probably be more difficult. Mechanics is going to be when you're talking about mechanics versus electricity and magnetism on Physics C, the actual like mathematical analysis definitely gets ramped up a bunch when you go to electricity and magnetism. There's just a lot more complicated equations there. But if you are a person who has very strong mathematical skills, calculus is no big deal for you. You're great at analyzing equations, all that stuff, but you don't do as well with reading questions, with picking out small pieces of information. Physics C might actually be easier for you than Physics 1 and 2. Physics 1 and 2, like I kind of said, focus on an even stronger emphasis on the laboratory skills and being able to analyze stuff that way. Should I take both AP Physics and SAT Physics? I'd say why not? I don't know if I would talk to specifically your college that you're going to be applying to and see how they use those specific scores. SAT Physics is only going to help you for entrance. So does getting a 4 or 5 on my AP Physics, is that looked on at the same level as getting a very high score on my SAT Physics? If that school is going to say, hey, if you get a 700, 800 on the SAT Physics, that's going to bump your application up, then I'd say, yeah, take both. Show that you really have mastered 2 different ways of doing physics. How long should I spend on a free response AP question? So normally I'd say about what it says in the box at the top. Normally I would say, okay, you have you have 90 minutes to answer that. And again, you're looking for individual points. You're not looking for 100%. So start with the ones that you know really well, squeeze every single point that you can get out of those, 1 or 2 questions you know the best, and then move on to the ones that you know less so. Try to get a moderate amount of points. And then if there's one that just completely blanks your brain, then, just try and write down what you can do. Ideally, you answer all 5 well, but sometimes it doesn't work out that way. For this year's test, they're specifically going to give you long answer, 25 minutes to answer it, and then 5 minutes to submit it. So you don't really have a choice. It's like do the best you can with that one question for 25 minutes. It's it's really hard when you only have 2 questions. You really hope that those are both on topics that you know, because if one of them's on a topic that you don't know, then that's going to be an issue. Yeah, so you basically, for this year, you just got 25 minutes for the long ones, 15 minutes for the short one, and you answer those the best as you can. So which is more difficult, AP Physics or SAT Physics? So AP Physics, as far as like how you answer the questions, is definitely harder. Having to actually think conceptually, being able to translate between quantitative and qualitative, being able to transfer information that way is definitely much more difficult. But everything on there is stuff that you learned in your high school physics class, right? So you've taken usually an AP Physics course that was devoted specifically to that material. Versus SAT Physics, they have all sorts of stuff on modern. A lot of people don't have some light optics, history of physics, stuff like that doesn't get taught in your high school physics courses, and so it takes some independent study, like the course that we do, devoted specifically to that. Okay, I think, yeah. So should I use the same strategies on AP and SAT? So obviously no, right? So SAT, we would go through and try and cover as broad a range as possible and make sure you know all the concepts, versus for AP Physics, we're going to drill in more on the specific types of questions and how to answer those, how to pull out the information. Some concepts as well, but focusing as much on those specific skills as possible. All right. Let me see. I think we're going to wrap up from there. Okay, so yeah, I think we're gonna end it there. If you're interested in any of our courses, contact 7EDU, and I think they're gonna close out. So I will disappear for a sec, and hope to see some of you online.
Thank you, Colin, and thank you everyone for attending today's open class. Colin's AP Physics will start in 1 week. If you are interested in this class, if you have any other questions toward AP test or other AP subjects, or if you want to take a free evaluation, feel free to contact us. Next AP open class is about AP English Language and Composition, AP English Literature and Composition with Amy. The time is 6 p.m. to 6:45 p.m. See you guys tomorrow. Bye-bye.